Hello everyone, we are group number 17 and this is our DIY project. We have made a smart fan which is basically temperature based speed control fan. Our objective is to control the speed of a fan based on the ambient temperature in the surrounding. The motivation behind the project was to build an application that can help to reduce the power consumption. Henceforth, the smart fan can reduce the power consumption only by using the optimum amount of power in accordance with the temperature. The main principle is to start the fan whenever the temperature reaches a threshold value. Then vary the speed of the fan as the temperature rises linearly above the maximum temperature and finally operate it at its maximum speed. Our team consists of 5 members: Chaitanya Singhal, Naina Sitara, Tanish Pratap Singh, Sameer Sen, and Muskan Turaha. Our work distribution was as follows: Chaitanya worked on Tinkercad model and the code, Sameer worked on hardware and its assembly, Naina worked on hardware analysis and the presentation, I, Muskan, has worked on code and information, and Tanishq has worked on PPT and presentation and the idea. This is a 4-week project timeline. These are the components we have used for the project, and our total budget turns out to be 1056 rupees. These are the important components we have used for the project: Arduino Uno, 12C LCD screen, an NPN transistor, and the temperature sensor. The software we have used are Arduino Uno IDE, Tinkercad, video editor, and Google Slides.
Hello, my name is Naina Sitara and my roll number is 21MI33013. This is the Tinkercad model for our project. These are the following components. We have a 9-volt battery, a 16 by 2 LCD screen, Arduino Uno, breadboard, LM35 temperature sensor, a 100 ohm resistor, LED, NPN transistor, and a fan. So these are the following connections. We have made the connection to the ground and the 5 volts pin in the Arduino. There is a 100 ohm resistor connected to the LED. The battery is connected to the Arduino Uno and a DC motor is connected to the breadboard as shown. There is a 16 by 2 LCD connected to the breadboard and Arduino. The output pin of the temperature sensor LM35 is connected to pin A0. The fan is connected to pin number 6 on the breadboard and the LED is connected to pin number 10. We have also connected the NPN transistor to the breadboard and the Arduino.
Hello, myself Chaitanya Singhal, roll number 21ME30024, and right now I will be explaining the code for our DIY project. So first, we import the two libraries required for the components of this project. Then we declare variables and assign the number of pins which we have connected in them. After that, we declare the pin modes in the code for the Arduino to run and write the LCD codes to begin and print the strings like temperature and fan. Then in the loop, we read the temperature from the temperature sensor using the given formula in the code, as you can see, and using the if-else condition, we determine at which temperature what speed the fan will run with. And in the last, we declare that the temperature will be read at every 1 second to improve the efficiency of the code. This is the entire demonstration of our code. Thank you.
My name is Tanish Pratap Singh, roll number 21PH10042. Now let's talk about applications of smart fan. It can be used for temperature control, and as we already know, then it can be used for PWM based output, where the speed of fan can be varied according to the duty signal or PWM signal. The circuit can also be used for heat reduction purposes in CPUs and other technical equipments. Next, let's talk about challenges faced. The main challenge during was assembly because of the problem with soldering. The next challenge was determining the correct analog pin. The third challenge was motor friction. We also had communication challenges among ourselves because of the online semester. Thank you.
Hello, my name is Sameer Sen and this is our group project, and we have made a temperature controlled fan. In this, the speed of the fan is controlled by the temperature of the room, and for making our project we have used the following parts. First of all, we use the Arduino Mega Board 2650 and LCD screen 16 by 2, and for feeding the temperature of the room we have used the temperature sensor LM36, and we have used a transistor of rating NNN2222, and we have used a 9 volt DC motor and a plastic fan and a 9 volt battery. Let's see the working of the project. So as you can see right now the temperature of the room is 25 degree, 22 degree, and when we connect the battery, right now the fan is rotating at 14%, and let's see what happens when we increase the temperature of the room manually by this soldering machine. So as you can see, when we put the soldering machine closer to the temperature sensor, the temperature of the room will increase for the sensor, and as you can see, as the temperature increases, the speed of the fan will increase. So now the temperature is 24 degrees Celsius and the fan is rotating at 29% of its full power. Now the temperature sensor increased the temperature 26 degree and the fan is 29 degree and fan is rotating at 44% of its power. Thank you so much. Cut.